Our topic is about limits and infinity. So, recap na natin yung mga pinag-aralan natin before. The first one is, a table of values or graph may be used to estimate a limit. So, para makuha yung limit ng function natin, pwede tayong gumamit ng table of values and also the graph para ma-estimate natin or matukoy yung limit ng ating function. Second, if the limit of a function at a point does not exist, it is still possible that the limits from the left and right at that point may exist. So ito naman yung limit ng function which is unbounded. Ibig sabihin, magkaiba yung limit ng nasa right hand, magkaiba naman yung limit ng nasa left hand. Okay? Hindi nag-i-exist yung limit but merong limits on the left hand and right hand. Okay, so tawag natin doon is unbounded. Third, if the limit of the function from the left and right exists and are equal naman, magkapareho, at nagtatagpo, okay, then the limit of the function is that common value. So para naman dito, na kung saan yung function natin on the left hand and right hand, magkakapareho lang yung limit, ibig sabihin limit of that function is defined. And that is the limit, kung ano yung magkakapareho. Okay, pag-usapan naman natin ano yung pinakaiba ng infinite limits at saka ng limit at infinity. So meron tayong dalawang terminologies here, okay? Again, we have the infinite limits versus the limits at infinity. Ano nga ba ang pinakaiba? So una muna natin pag-usapan yung infinite limits. Let's consider the basic rational function. We have your f of x is equal to 1 over x with its graph. So using Desmos application, this is the graph of your f of x is equal to 1 over x. So tingnan natin, anong mangyayari sa value ng f of x habang yung value ng x natin approaches 0 from the left. Okay? So gamit yung table of values, we will set your x as negative 0.1, negative 0.01, so on. So ito yung mga values ng x natin is approaching 0, papuntang 0. So ibig sabihin, our x increases until it reaches 0. So define the value of your f of x. Lahat ng ibinigay nating value for your x, papalitan lang sa expression nito. So let's say for example, if your x is negative 0.1, define the value of f of x, that is simply 1 over negative 0.5. Using calculator, it will give us a function of negative 10. So kung yung x daw is negative 0.1, the value of your f of x is negative 10. Okay? So if x naman is negative 0.1, your f of x is negative 100, so on and so forth. So ano ang napapansin mo sa f of x natin? Anong nangyayari sa value ng f of x? From negative 10, naging negative 100, naging negative 1,000, negative 10,000, and negative 100,000. So yung value ng f of x natin is approaching to negative numbers, which is yung pinakamaliit na negative number. Okay? Papunta siya sa negative smallest number. And that number is negative infinity. Okay? So, yung nangyayari sa values of f of x natin habang yung x natin approaches 0 from the left. So, tingnan naman natin, ano mangyayari naman sa value of f of x as x approaches 0 from the right naman. Okay, so we will set again ng value ng mga x mo. So, let's say, ito yung mga numbers which is from the right of 0. So, 0.1, 0.01, 0.001, until to 0.0001. So define the f of x again. Palitan nyo lang yung value ng x mo dito. Since our x is 0.1, so 1 divided by 0.1 is 10. If x is 0.01, f of x is 100, so on and so forth. Kanina, yung mga value ng f of x natin is approaching to negative infinity as x approaches 0 from the left yun. Okay? So ngayon, as x approaches 0 from the right, ano ang nangyayari sa f of x? From 10, naging 100, naging 1,000, naging 10,000, and naging 100,000. So the values of your f of x increases. Okay? Pataas ng pataas until it reaches to positive infinity. So based on the table natin, so masasabi natin as the value of x becomes sufficiently close to 0 from the right, the value of the function gets larger and larger, katulad nito, without a bound. So ibig sabihin, papunta siya sa positive infinity natin. Okay? So the value of your f of x is going infinitely to the positive side. Katulad kanina sa una nating table of values, habang yung x natin becomes sufficiently close to 0 naman from the left, the value of the function gets dramatically smaller without a bound. So, ibig sabihin, parating or papunta sa negative infinity naman yung value ng f of x as x approaches 0 from the left. Okay? So, ibig sabihin, so here, we can conclude if x approaches 0 from the left, okay, so yung mga value ng f of x natin is approaching to negative infinity. And that is, limit of 1 over x as x approaches 0 negative is equal to negative infinity. Ano naman yung limit nito? Okay? Kung yung x natin is approaching 0 naman from the right, okay? So yun nangyayari sa f of x natin is what? Lalong lumalaki ng lumalaki. Thus, the limit of this function is positive infinity as x approaches 0 positive. Okay? Then, we can conclude that the limit of the function as x approaches 0 negative is not equal to the limit of the function as x approaches 0 positive. So dito nakikita natin that the limit does not exist. Okay? Kasi kung gagamit tayo ng direct substitution, malalaman naman natin talaga that walang nag-i-exist na limit on here. Okay? So by direct substitution, the limit is 1 over 0 or undefined. So again, the limit does not exist. But merong limit on the left hand at meron ding limit on the right hand. Yun nga lang, magkaiba. Unbounded yung limit. It does not exist. Okay, to conclude, if the value of f of x arbitrarily increases positively for all x sufficiently close to c from both sides without letting x to c, then limit of the function as x approaches c is equal to positive infinity. Likewise, if the value of f of x arbitrarily increases negatively for all x sufficiently close to c from both sides without letting x to c, then limit of the function as x approaches 0 is equal to negative infinity. Ulitin ko lang na meron tayong dalawang limit for the infinite limits. Okay? Kasi by direct substitution, the limit of the function is undefined, unbounded. Isang limit is positive infinity and the other limit is negative infinity. We have vertical asymptote. The line x is equal to c is a vertical asymptote if of f of x provided that any of the following limits at x is equal to c are satisfied. Meron naman tayo dito ang apat na graph, okay? Para masabi natin that the line x is equal to c is a vertical asymptote of your function. The first one, ito ang graph na paakyat to the left of your y-axis. The limit of the function is equal to positive infinity as x approaches to c negative. Okay? Positive infinity kasi nga paakyat tayo ng y-axis. And now we'll see here with an apostrophe negative kasi nasa left part siya ng ating y-axis. Second graph is pababa naman. Okay? At the same time, nasa left part ng ating y-axis. Limit of this function as x approaches to c negative also is equal to negative infinity naman. Kasi pababa na yung graph natin. The third is, itong graph na nasa right axis, y-axis natin, then paakyat, the limit of this function as x approaches c positive, kasi nasa right, is equal to positive infinity, kasi paakyat naman siya. And last, we have limit of the function as x approaches c positive, kasi nasa right yung graph natin, is equal to negative infinity kasi papuntang baba na ng y-axis yung ating function. We have theorem under vertical asymptotes. Suppose the limit of f of x as x approaches c is equal to L, and limit of g of x as x approaches c is equal to 0. We have, unang condition, kung yung limit natin is mas mataas sa 0 if your L is greater than 0, and g of x approaches 0 positive as x approaches c, then we can say that the limit of f of x over g of x as x approaches c is equal to positive infinity. The second one, same. Kung mas mataas yung value ng L natin kaysa sa 0, and g of x approaches 0 negative as x approaches c, then limit of two functions, or the quotient of two functions as x approaches c is equal to negative 8 naman. Okay, the other condition, kung mababa naman yung L compared to 0, then we have this one. Yung g of x approaches 0 positive, then the limit of the two function is equal to negative infinity. And g of x approaches 0 negative, then limit of our rational function is equal to positive infinity. So ito lang yung tatandaan natin. If the value of your L is greater than 0 and g of x approaches 0 positive, or that is on the right part of your 0, then the limit is positive. Okay? Pero kung g of x natin approaches, your function is approaching to the left of your c, then your rational function equals negative 8. Okay? Kung mababa naman yung L, wherein g of x natin approaches to the right hand of your 0, then limit is negative infinity. Okay? If g of x, again, approaches to the left hand or to the left part of your 0, then the rational function is equal to positive infinity. Example. So let's evaluate the limit of 4 over x cubed as x approaches 0. So this is our rational function, and we need to find the limit as x approaches 0. So kung gagamit tayo ng direct substitution, we could get undefined. Okay? So by direct substitution, palitan lang yung value ng x to 0, we get 4 over 0 cubed, or that is 4 over 0. And we all know 4 over 0 is undefined. Okay, it is impossible to find the exact value. But again, okay, wala siyang limit. Limit does not exist, pero may kanya-kanyang limit on each hand of the function. Iba yung limit na nasa right hand of the function, at iba naman yung limit ng nasa left hand ng ating function. Okay? Kaya naging undefined siya. Limit does not exist. So ito yung hint that the function approaches infinity. Okay? So we need to reconcile whether it is a positive or negative infinity. So let's solve. So para makuha yung limit from the left, x should be as close to c. Okay, which is your 0. Dapat mas malapit sa 0. Okay? So let's say x is equal to negative 0.1. Kasi ito yung malapit or pinakamalapit na number from the left of your 0, which is negative 0.1. You can use negative 0.01, negative 0.001, which are closer to your c from the left. Okay? Then, by direct substitution, palitan lang natin yung x. So we have 4 over the cube of negative 0.1. Then simplify lang, okay, to come up with the quotient of negative 4,000. So yung sagot dito is negative 4,000. This means that from the left, the graph approaches negative infinity as x approaches to 0. And thus, the limit of the function is equal to negative infinity. So, ito, yung sinet nating values, okay, for your x, ito yung magiging reference. Yung sagot, yun yung magiging reference either positive or negative yung infinity na magiging limit ng function natin. Okay? Okay, how about, tingnan natin yung limit from the right. Okay? So, yung nasa kanang bahagi ng 0 natin is 0.0001, 0.0002. Okay? So, here, I'll use x is equal to 0.1. Ito naman yung nasa right part ng ating c, which is 0. Okay? Then, substitute lang din. So, we get 4,000. And 4,000 is positive. Therefore, limit of the function as x approaches 0 positive is equal to positive infinity. Then we will compare the two limits. The left hand, okay, this is the left hand limit, and this is the right hand limit. Are they the same? No, they are not the same. And then we can conclude that the limit of the function does not exist. Okay, limit of the function does not exist. So at this point, the presence of vertical asymptotes here, this is your vertical asymptotes, and this is also your vertical asymptotes. When we talk about vertical asymptotes, sa algebra, these are vertical lines that the curve approaches as it goes to infinity. In rational functions naman, vertical asymptotes occur at values corresponding to zeros of the denominator. And more formally, vertical asymptotes can be defined gamit po yung limits na pinag-uusapan natin kanina. So that is your vertical asymptotes. Another example, let's evaluate the limit of this function, negative 6x squared over x squared minus 1. So to get the specified limit, kailangan nating iset yung value ng x natin which is closer to your c. In this case, yung c natin is negative 1 from the left kasi negative yung exponent ng c natin dito. Okay? Yung gawin natin dito, substitute it to the given function. Okay? So dito, nagset ako ng x natin which is negative 1.1. Bakit negative 1.1? Kasi yung c natin is negative 1 and we have here the superscript which is negative. Okay? Ibig sabihin, kukuha tayo ng value ng x which is nasa left part ng negative 1. In this case, gagamit ako ng x is equal to negative 1.1. By substitution, okay, pinalitan lang yung x, then simplify, then the estimated value is negative 34.571. Okay, so i-reject lang natin yung number na nakuha natin. We will look only for the sign either positive or negative. And then we can conclude that the limit of the function as x approaches negative 1 negative is equal to negative infinity. Okay, alamin naman natin yung limit ng ating function. In this case, we have x approaches to c positive naman. Okay, so ito, titingnan natin yung values ng x which is negative 1 from the right. Okay, so we have limit from the right. So I let x is equal to negative 0.1. Kasi sa tingin ko, ito yung value ng x which is right to the right of your negative 1. Okay, so negative 0.1. So again, to get the specified limit, let x be sufficiently close to your c, which is negative 1 from the right, and then we will substitute it to the given function. And then we will get, okay, ito, substitute lang, lahat ng x magiging negative 0.1, then simplify to get an estimated value of 0.06. Again, we will reject the number. We will look only for the sign. Okay? Kung yung pinag-uusapan natin is vertical asymptotes. So, positive ba or negative yung 0.06? 0.06 is a positive. Thus, the limit of your function as x approaches negative 1 positive is equal to positive infinity. So, ito yung paraan kung paano kunin yung vertical asymptotes natin or limit on the vertical asymptotes. So, makukonklud natin that the limit is unbounded. Limit does not exist. Kasi nga, negative yung nasa left hand, positive naman yung nasa right hand. So, dakot naman tayo sa limits at infinity. Ano nga ba yung pinagkaiba ng infinite limits at saka ng limits at infinity? So, ulitin na natin that the infinite limits give information on the existence of vertical asymptotes on the graph of the function. Yung limits at infinity naman, on the other hand, ginagamit siya para maipakita that there is an existence of horizontal asymptotes naman. Kanina sa infinite limits, pinapakita doon na merong existence of vertical asymptotes. Dito sa limits at infinity, pinapakita ginagamit ito para maipakita yung horizontal asymptotes. Okay? Pag-usapan natin later kung ano yung horizontal asymptote. So, balikan natin yung rational function natin, which is f of x is equal to 1 over x. So, this is the graph again of your f of x is equal to 1 over x. What happens as x increases without bound naman? So kanina, we let x approaching 0. Ngayon, we will let x increasing without bound. Ibig sabihin, papunta siya ng positive infinity. Okay? Pag decreases naman without bound, papunta siya sa negative infinity. So ano kaya yung mangyayari if your x approaches to both or either positive or negative infinity? So using table of values, mag-set lang ulit tayo ng x na kung saan pataas na. Okay, kasi ito yung hinihingi sa atin as x increases without bound. So nag-set lang din ako. Gumawa ko ng values of your x which are 10, 100, 1,000, 10,000, 100,000. Okay, so para makuha yung f of x, papalitan lang din natin yung mga values ng x natin, okay, to your expression 1 over x. If x is equal to 10, then f of x is 1 over 10, or that is 0.1. If x is 100, then f of x is 0.1, so on and so forth. So ano yung napapansin natin sa values ng f of x? Yung value ng x natin is pataas ng pataas without bound, without limit. Okay? So until it reaches to positive infinity. So ano ang nangyayari sa value ng f of x? From 0.1, naging 0.01, naging 0.001, until to 0.0001. Ibig sabihin, papunta siya sa 0. So habang yung x natin papuntang positive infinity, the value of f of x becomes 0. Okay? Next question. Ano naman ang mangyayari kung yung x natin decreases without bound naman? Okay? So, we will take negative number for the values of x. So, ito yung values na binigay ko. So, x is equal to negative 10, negative 100, negative 1,000, negative 10,000, negative 100,000. So, para makuha yung f of x, ganun pa rin yung rule. Papalitan lang yung x dito. If x is negative 10, then f of x is negative 0.1, so on and so forth. So, yung x natin papuntang negative infinity. Okay? So, ano nangyayari sa f of x from negative 0.1, naging 0.01, naging negative 0.001, negative 0.001, negative 0.0001. It is also approaching to 0. Okay? Katulad kanina, kung yung value ng x natin papuntang positive infinity, the f of x is also approaching to 0. Okay? Ganun din yung case ni x decreases without bound naman. Yung x natin na papuntang negative infinity, it results to f of x is equal to 0. Yun naman yung limits at infinity. Na kung saan, yung c natin is infinity. Okay? Then we could say that limit of the function as x approaches negative infinity or infinity negative is equal to 0, and limit of the function as x approaches infinity positive is equal to 0 also. So limits at infinity thus exist. Kanina sa infinite limits, limit does not exist. Yun yung isa sa mga pinagkaiba ng infinite limits and limits at infinity. Then, we could say that the limit of f of x as x approaches positive infinity is L if the value of f of x get closer and closer to L as the values of x increase without a bound. And we have also the limit of f of x as x approaches negative infinity is L if the values of f of x get closer and closer to L as the values of x decrease without a bound. And now, in limits at infinity, dito na natin makikita that there is an existence of your horizontal asymptotes. So when we talk about horizontal asymptotes, ito yung mga horizontal lines that the curve approaches as it goes to infinity. So the line y is equal to L is a horizontal asymptote of the function provided that any of the following limits at y is equal to L are satisfied. Ito yung una, limit of the function habang yung x natin is papuntang negative infinity, that results to your L. Then we have also the limit of the function habang yung x naman natin is papunta sa positive infinity, results to L. And this is the graph of your horizontal asymptotes. Kanina sa vertical asymptotes, the direction of the graph is papuntang taas or baba. Okay? In line with your y-axis. Ito namang horizontal asymptotes, either papuntang left or papuntang right. Okay? In line with your y-axis. So in horizontal asymptotes, meron tayong mga theorem. So these are the theorem under horizontal asymptotes. Una, if c or your constant is an element of your real number, then we can say that limit of the constant as x approaches the positive infinity is also a constant. So para din siyang constant law. Okay? That the limit of the constant is also a constant. Number two, if n is even naman, okay, when we talk about even, these are numbers which are divisible by 2. Then limit of x raised to n as x approaches positive or negative infinity is equal to positive infinity. So yung n na tinutukoy natin dito is the power of your function. Kung yung power down ng function natin is even, ends with 0, 2, 4, 6, 8, then the limit is positive infinity. Okay? Number 3, kung add naman daw yung power natin, then the limit is a positive infinity naman if x approaches to positive infinity. Habang negative infinity naman yung magiging limit ng function nyo if x approaches negative infinity. So ito yung tatandaan natin pagdating sa power ng ating function as your x approaches to either positive or negative infinity. Number 4, limit of 1 over x to the nth power as x approaches positive or negative infinity is equal to 0. So, importante yung theorem na to kasi magagamit siya sa rational functions na kung saan yung x nyo is approaching to either positive or negative infinity. Okay? Malaki yung magiging importansya ng number 4 theorem natin. Number 5, let's see, is an element of real number. Limit of your f of x as x approaches to positive or negative infinity is equal to c, and limit of g of x as x approaches positive or negative infinity is equal to positive or negative infinity. So tatandaan nyo yung mga theorem na to on horizontal asymptotes kasi kakailanganin natin later siya, okay, para makuha yung limit ng function natin. Example, evaluate the limit of the function x to the fourth power minus 2x cubed as x approaches infinity. So kung gagamit tayo ng direct substitution, we get infinity to the fourth power minus 2 times infinity to the third power. At alam naman natin na yung positive infinity to the fourth power here is positive, then the answer is positive infinity. Okay? Answer here is positive infinity. Here naman we have infinity to the 3 power or infinity cube. Then the limit of this expression is negative infinity. And we are not allowed to subtract positive infinity and another infinity. Okay? So, hindi pwedeng i-combine yung positive infinity at saka yung negative infinity. So, this makes the function indeterminate. Okay? Katulad din siya ng 0 over 0, which is also indeterminate. So, here, positive infinity minus infinity is indeterminate. Meron siyang value, but we don't know the exact value. Okay? So, pupunta tayo sa factoring. Okay? Katulad ng rational function, kung hindi kaya ng direct substitution, we will go to the factoring method. Ito yung pangalawa. Okay? So, if-factor natin yung function natin, which is x to the fourth power minus 2x cubed. So, common lang, common monomial factor, ilalabas lang natin yung x to the fourth power. Okay, pwede din, or x cubed. Pero dito, gumamit ako ng x to the fourth power. Para meron tayong presence of, eto, yung form kanina, yung theorem number 4, which is the limit of 1 over x to the nth, di ba? Which results to 0. So, eto yung factor ng ating x to the fourth minus 2x cubed. X to the fourth times 1 minus 2 over x. Okay? So instead of this function, we will use the factor form of that function para makuha yung kanyang limit as x approaches to positive infinity. So next natin gagawin, papalitan lang yung x natin with infinity. So we have infinity to the fourth power times 1 over 2 over infinity. Alam natin kanina, by theorem number 4, the limit of 1 over x to the nth power as it approaches to infinity is equal to 0. So this makes 0 na. Ito naman, infinity to the fourth power is even, then the answer is positive infinity. Okay, simplify lang natin. Magiging positive infinity na siya. Copy the 1, this becomes 0. Okay, so 1 minus 0 is 1 times the infinity is also an infinity. Thus, the limit of the function as x approaches infinity is equal to positive infinity. Another example, evaluate the limit of the function 8x minus 5 over 2x plus 3 as x approaches negative infinity. Okay? So, dito, tandaan nyo lang yung indeterminate form natin, which is infinity over infinity. That is indeterminate. Yung technique dito, i-multiply lang natin yung numerator and denominator by 1 over x to the nth power. Na kung saan yung n is the degree of your denominator. Since yung degree dito is 1, so mag-multiply tayo both part of this fraction by 1 over x lang. Kanina, 1 over x fourth power, kasi nga yung degree is 4. So dito naman, the power is 1, then mag-multiply tayo both numerator and denominator by 1 over x raised to n. Okay? So factoring method na tayo. Hindi tayo pwedeng gumamit ng direct substitution because it will result to indeterminate. Okay? So factor muna natin yung function. So we have 8x minus 5 over 2x plus 3 multiplied by 1. Again, yung 1 na yun is your 1 over x. Okay? So 1 over x divided by 1 over x. This is also equal to 1. Then, i-multiply natin yung 1 over x to each part of your numerator. Okay? So say 8x times 1 over x, that results to 8x over x, or simply 8. So sa negative 5 naman, i-multiply kay 1 over x, that results to negative 5 over x. Punta tayo sa denominator, 2x multiplied by 1 over x, that is 2x over x, or simply 2. 3, ibibigay kay 1 over x, that is positive 3 over x. So ito na yung bagong mukha ng ating function using factoring. Okay? Then, papalitan lang din natin. Okay, so instead of this function, we will use this function. Kasi alam naman natin that any number divided by x as x approaches to infinity is 0. Kaya medyo madali na yung pag-solve natin dito. Okay? So substitute natin. Lahat ng x magiging infinity. It will result to 8 minus 5 over infinity over 2 plus 3 over infinity. So lahat ng number divided by infinity is equal to 0. So copy yung 8 minus, ito, maging 0 siya. Ito, copy yung 2. 3 divided by infinity is 0. Then simplify lang. That is 8 divided by 2. And the answer is 4. Thus, the limit of the function as x approaches the positive infinity is equal to 4. Simple as that. Okay, for the final word, the only way to learn mathematics is to do mathematics. See you.